To learn about the normal distribution, we use the example of pregnant women in Sweden. All nations keep a good statistics on pregnancies and birth rates, etc. And so here we use the example of Sweden. We assume that the duration of pregnancies in days is normally distributed, that the average time duration is 281 days, which corresponds to 40 weeks plus 1 day. And then the standard deviation is sigma is 13 days. A pregnancy is considered to be full term if it lasts between 266 and 294 days, which is 38 to 42 weeks. So I'd like to answer two questions. What is the probability that a Swedish woman has a full-term pregnancy? And what is the probability that a Swedish woman has a post-term pregnancy, which means more than 42 weeks? So lots of text here. Let's put all this into formulas. So what are the formulas? The formula, we have the mean, we have the standard deviation. We know it's normally distributed. Then we should be able to write down the probability density function f. Here is again the mu, here the sigma, and here is f. And that's the formula for the normal distribution, right? Where this one here is a sigma, and this one is also sigma, and this guy is a mu. So if you look it up in your notes, then you will see that this formula is the same. And here I draw the curve of the probability density function f. What did we have to do? Right. What is the probability that a Swedish woman has a full-term pregnancy, meaning between 266 and 294 days? This means, again, we want to have an area under the curve. So let's say this is 266. And then the other limit is 294, maybe somebody here. And so we are interested in this area. This gives a probability. P 266 less or equal T less or equal 294. Okay? So integral 266, 294 of this monster formula there. 1 over 13, 2 pi root, and then e to the minus a half t minus 281 over 13 square dt. So now this is also a difficult integral, and this is also something which I cannot solve with elementary functions. So again, I'm heading over to Wolfram alpha. Here I just write integrate 1 over 13 times square root of 2 pi, closing brackets, and then the exponential of minus 0.5 times the x minus 281 over 13 squared, and then integrate this from 266 to 294. You just type it in like this in one line. And so what it does, it gives you the answer, 0.717063. Even more so, it shows you this nice graph of the area under the curve. Basically what I have drawn out already. So what's our answer? 0.7170. So which means about 72% of women in Sweden have a full-term pregnancy. So then the other question should be easy. Post-term pregnancies are more than 294 days. So here's again the 294 thing. And now I'm interested in all this, which is bigger. Which then becomes the integral from 294 to infinity. 1 over 13 root of 2 pi e to the minus a half t minus 281 over 13 square. So let's do the Wolfram alpha thing again. And let's see if we can just sub in infinity for the upper limit. So typed in infinity there, and the result is right here. 0.1586. There we go. So about 16% of Swedish women have post-term pregnancies.